Hello, you are welcome to this lesson. In this lesson, we are going to learn about network topology. After this lesson, you will be able to understand what a network topology is, in a practical perspective. You will also be able to know the different types of topologies we have and their various ups and downs. After that, you will be able to know the most efficient network topology we use in this modern-day technology. But before we start, let's remind ourselves with the last topic we learnt in the Network Devices module. In our previous lesson, we learnt about repeaters, bridges, hubs, and wireless access points. We saw how hubs transmit data packets across a network. We learnt that, when a hub receives a data packet, it broadcasts it to all the nodes in the network, making it not too intelligent as compared to switches. We also spoke about bridges. We said that bridges connects two network segments together, giving them a separate collision domain so that there wouldn't be too many data collision and traffic on the network. Again, we learnt about repeaters and how we can use them to amplify data signal and also extend the distance by which a data signal could be transmitted. We also saw the types of repeaters we have in the field of networking. Lastly, we learnt about wireless access points, what they are used for, and how different they are from routers. Please watch the previous lessons if you have not done so, before you continue with this one. Starting with today's lesson, let's see what a network topology means. When we say network topology, we are talking about the arrangement of the various nodes on a network, how the nodes are connected with each other, and how they transmit data to each other. These arrangements can either be physical or logical. Physical topology talks about how the nodes are arranged physically in a network. And logical topology, on the other hand, talks about how these nodes transmit and share data. There are about 6 different types of topologies we can talk about today. The first one is the bus topology. In a bus topology, all the nodes are connected to each other through a single cable called a backbone. This cable will then have to be terminated at both ends with what is called a terminator. What this terminator does is that it absorbs the signals when they reach the ends of the cable to prevent interference. This topology was the first implementation of an Ethernet network. To implement this, the network interface controller, which is known as the network card, usually had a port called BNC port and is connected by a connector called a BNC connector. This is a BNC connector, a male connector and a female connector. And here is a network card with a BNC port. These BNC connectors are usually connected by a cable called coaxial cable. This cable is mostly used in today's video production and satellite dishes connection. We will learn more about this cable when we get to network cables and signal transmission medium in later videos. Let's now look at how data is transmitted in this topology and some advantages and disadvantages. In this example, there is only one collision domain. Meaning, when host A sends a packet to host E, this packet will be transmitted to all the other hosts, making the network insecure. Also, when two hosts send data packets at the same time, there will be data collision. When this happens, both devices must stop and try again later. Each device waits a different random amount of time before trying again. This is called half-duplex mode of transmission. Half-duplex data transmission means that data can be transmitted in both directions on a signal carrier, but not at the same time. Network efficiency decreases rapidly whenever you add another device. However, in this topology, if one node breaks down, it does not affect the other nodes. It is very cheap and easy to implement this topology. It is also good for small businesses, but not recommended in this modern times. The next type of topology we will look at is ring topology. In a ring topology or token ring topology, Computers are connected to each other in a circular format or a closed loop. This means every device in the network will have two neighbors. In this example, if host A sends packets to host F, the packet will travel through all the nodes in this network before it gets to the destination host F. In this topology, data transmission is usually unidirectional. This means data travels in one direction. There is no collision in this topology. This is because one node is chosen to configure the network and monitor other devices. So, before one device forwards a packet, a token is generated, allowing that device to forward the packet to the next device. This is why it is called a token ring topology. It can be made to support a full duplex transmission. This is possible by connecting other cable to ensure continuity through redundancy. When this happens, data can then travel in both directions, and it is then called a dual ring topology. Cost of implementation is relatively low. To talk of disadvantages, the failure of one node can take the entire network out of operation, which means it is not fault tolerant. It also not easy to scale. And making changes to a ring topology is also complicated because you need to shut down the entire network to effect any changes. The other topology to talk about is the star topology. This is the most widely used topology across the globe. It uses either a hub or a switch as a central node through which all other nodes are connected. As discussed in previous videos, this network is the most efficient and reliable technology. It is more scalable. Collision of data is drastically minimal depending on the central node type used. It is also fault tolerant. This is because, if one node fails, it does not affect the other nodes. However, if the central node fails, the entire network goes down. It is also relatively expensive as cost of switches are high. The next topology type to talk about is tree topology. As the name suggests, a tree topology network is a structure that is shaped like a tree with its many branches. Tree topologies have a root node that is connected to another node in a hierarchy. The hierarchy is parent-child where there is only one mutual connection between two connected nodes. For example, when we have a host here, we can connect other hosts like these to form a tree topology. In this case, this becomes the parent node through which other nodes are connected in a hierarchical manner. In computer networks, a tree topology is sometimes known as a star bus topology. This is because it combines features of both star and bus topologies to create a tree-like structure. In this example, every branch contains star network, and its main structure is designed in the form of a bus backbone cable. Therefore, the primary bus is attached to one or more buses and switches, which further connects to one or more network devices and network nodes. It is a very flexible computer networking method that allows you to add network devices to this network by simply expanding the star network at each branch of a tree. In this case, when this node fails in this hierarchy, it only affects the children nodes in that hierarchy. A real-world example is that when you have a multi-story building and wish to establish clusters at each section of the network, you can utilize tree topology. If you have departments and subdepartments, you can segregate the whole tree network with the help of several switches that makes the entire network easy to maintain and more manageable. To talk of the advantages of a tree topology, it is more scalable. 2. One node failure does not affect the entire network. For example, if this switch fails, it only affects the nodes in this hierarchy. 3. A tree topology network can be managed and maintained easily. 4. In a tree topology, the management and establishment are much like a star topology network. To talk of disadvantages. 1. This topology is costly. This is because it uses both bus and star topology. 2. It also involves a lot of cables. The next topology to talk about is the mesh topology. A mesh topology is a point-to-point connection where each node is connected to every other node in a network. In this form of topology, data is transmitted via two methods, routing and flooding. Routing is where nodes use routing logic to work out the shortest distance to the packet's destination. In contrast, flooding is where data is sent to all nodes within the network. To talk of advantages of this topology. 1. This network is almost impossible to take down. 2. A breakdown of one node does not affect the others. 3. This network is scalable. 4. Adding new devices does not affect the network. However, this network is costly compared to others. It has a complex structure. 3. The risk of redundant connections is high. When I say redundant connections, I mean some of the connections may be idle. This is because packets will most of the time find the shortest route possible to their destinations. 4. There is high risk of traffic when every node decides to broadcast data. The next topology to know is hybrid topology. This is a type of topology that uses two or more different network topologies. In this example, we have a ring topology connected to a star topology. This topology is very efficient and reliable. It also scalable as it employs two or more different topologies. However, this topology can be too complex as it merges different topologies. It is also expensive to establish this topology. I believe you have well understood the various types of network topologies, their merits and demerits. Kindly subscribe to the channel and share for others to watch. Thank you and see you in the next lesson.